fractional exponents. Fractional exponents are another way to indicate radical operations. So if we had the square root of x, using a fractional exponent, that would be x to the 1/2. Now, the index, which is the number that would fall in here, when there's no number there, it's understood to be 2, goes in the denominator of the fractional exponent. So x, the square root of x will be x to the 1/2. The cube root of x would be x to the 1/3. And the 7th root of x would be x to the 1/7. Okay, if you are given an expression, let's say like the cube root of x squared y, and you're asked to write that using fractional exponents, then you take each factor under the radical, and this will be x, and the exponent goes in the numerator, the index goes in the denominator, so that'll be x to the 2/3, y to the 1/3. Another example, if we had the 4th root of x to the 3rd m to the 5th, then using fractional exponents, this would be x to the 3/4 m to the 5/4. Now you note that that's an improper fraction, but you don't change it to a mixed number. You leave it as an improper fraction. Okay, if you had an expression, let's say like x squared times the square root of x to the 3rd, and you're asked to simplify that and write your answer using fractional exponents. Okay, this would be x squared times x to the 3 halves. And then, since they're multiplied, you need to simplify that. So x squared, since this has a denominator of 2, we will write x squared with the denominator of 2, which would be x to the 4 halves times x to the 3 halves. And then, since we're multiplying, we know that we add the exponents. So if we add here, we'll get x to the 4 halves plus 3 halves, which would be 7 halves. All right, let's look at some additional operations with fractional exponents. Let's say that we had 3x times the cube root of xy plus 4 times the cube root of x to the 4th y plus 6. Okay, we can't combine like terms because they don't look like they're the same. So the first thing we need to do is see if we can simplify some things out. So here, if I look at the second term, I see that under the radical I have x to the 4th y, and since it's the cube root of that, I can simplify this so that I have 4 cube root of x to the 3rd times x times y. So that x to the 3rd will come out, and that will make that 4x cube root of xy. And then my first term was 3x cube root of xy. And then finally over here, I'll add the plus 6. So now the radicands are the same on the first two terms, so I can combine their coefficients. So 3x plus 4x gives me 7x times the cube root of xy plus 6. And these can't be combined because there's no radical on the 6. So then this becomes the answer.